Hello everyone! In this video I will show you that the same chemical could have different biodegradation depending on the test protocol. This difference could be explained by different probabilities of occurrence of the transformations applied on the target chemical. A metabolic similarity tool implemented in Catalogic allows comparison of simulated maps between chemicals within the same metabolic model or simulated maps of the same chemical produced by two different models. Part 2 of this video will exemplify the metabolic similarity of a same chemical within the different OECD test protocols for biodegradation, 3.1C and 3.1F. We have a target chemical, trimethylamine. Given the nature of both test protocols, it is expected to get a lower biodegradation result from the 3.1C model, as it is a more conservative biodegradation test than the 3.1F. However, in the current case study, trimethylamine is observed and predicted as readily biodegradable in the 3.1C model, and predicted as not readily biodegradable in the 3.1F model. These conflicting results could be explained by different metabolism of the target chemical simulated by both biodegradation models. In this case, the metabolic similarity tool could be very useful. The available three metabolic similarity criteria which could be used for comparison are already explained in part 1 of this video. Let's compare the simulated metabolic maps of this chemical by their common metabolic transformations. We will take into account the specificity of metabolic transformations and frequency of their application. In this way, we will get the real picture of comparison. The metabolic similarity between the simulated maps is very low. Let's explain the result. The bar diagram shows that although the same transformations are occurring in both simulated maps, the application frequencies of these transformations are different. Moreover, the same transformation, for example oxidative end dealkylation, has different probabilities of occurrence in compared models. Probability almost 1 in the Catalogic 3.1C model, and much lower probability of the same transformation in the Catalogic 3.1F model. The difference in probabilities leads to the different amounts of the parent chemical and degradation products as shown in the distribution charts. The target is exhausted as a parent at 28th day, and stable products are formed as a result of biodegradation in the Catalogic 3.1C model, whereas same target is really stable in the Catalogic 3.1F model and its degradation products have negligible amounts. This difference could be also justified by the probabilities the metabolites to be generated. Can you see the difference? It is obvious. It is important to understand that the probabilities of the transformations are derived from the observed biodegradation data of the training set chemicals. In summary, the different probabilities of the same transformations occurring in the Catalogic 3.1C and 3.1F models explain the difference in the predicted BOD values for trimethylamine. Thank you for watching this video. If you are interested in Catalogic, please contact us. The links will be below.